Namaste to all. This is JV and Dr. Vishal Saxena. I am professor in Department of Science and Technology under the Faculty of Education and Methodology, JVWU Women's University, Jaipur. Today I am discussing on the lecture of interpolation and the two formulas of forward and backward interpolation formulas given by the Newton's Gregory, and the today's lecture is from the program of BSc B.Ed 8th semester and of the university. So today I am going to discuss about on these topics on these topics. So today first we take the concept of interpolation. What is interpolation? Interpolation means that is simply we can define this interpolation as like suppose we are having some values of x and y, and y means that is a function fx, and the values of x are suppose equally spaced or not equally spaced here. In this case the unknown value of function y, that means it is fx, for the some corresponding value of x, this process is known as the interpolation. So interpolation means this is a statistical method which can be used to estimate an unknown value of a function fx to a corresponding value of the independent variable x. So there is x is called the independent variable and y is the dependent variable. So y means fx is the dependent variable, and that is the unknown value for this fx or the y is to be determined and for some corresponding value for some particular value of x. So this method is called interpolation. So this is interpolation. Just we have discussed about this, and now here, as already we know that here we have discussed already the forward and backward and the central difference tables. So now we take here the first formula, that is known as a Newton's Gregory forward difference formula, or it is also known as a Newton's Gregory forward interpolation formula. So this formula just it will give you the value of function fx for the some particular value of x, and where x can lie at the beginning of the given table here. So I am describing all the things these here. So first see this one here, Newton's Gregory forward difference formula, and just it is the definition which I have already explained here. This formula will give us the unknown value of function y, that means it is fx, for the some particular value of x which is coming at the beginning of the the table or the values of x and y. So now we come to the next slide. So see this one here, this is the Newton's Gregory forward, it is here Newton's Gregory forward interpolation formula. It is forward difference formula. Actually this one is this is the Newton's Gregory forward difference formula. So Newton's Gregory forward difference formula is given by, this is yx. Yx means here the function yx, and it is to be calculated here for the some particular value of x. This yx is equal to yn. This is plus u into del yn plus u into u plus 1 upon 2 factorial, or just we can define it here the exactly notation should be taken as here in the terms of y naught. We can take here in terms of yn also, but y naught is the better way. So that is the Newton's forward interpolation formula is yx is equal to y naught plus u into del y naught plus u into u minus 1 upon factorial to del square y naught. Then in the similar way, in a similar format, we have to proceed the next series here. So it is here plus u into u minus 1, u into u minus 1 into u minus 2 upon 3 factorial del q y naught, and in the similar way we have to take the next terms. So this is called the Newton's forward interpolation formula, and in the similar way so here we are discussing the one of the question here for the forward and the backward interpolation formula, and Look at this one here. This is the Newton's forward interpolation formula. And one more formula I have to discuss about that. That is called the Newton's backward interpolation formula. What is Newton's backward interpolation formula? Newton's backward interpolation formula will give us the unknown value of function y or fx for some particular value of x which is coming at the just ending or the end of the given table or the given prescribed values. So look at here. This formula this is the forward interpolation formula. This is the forward interpolation formula. This one is here, and this is the backward interpolation formula. What is this formula here? Yx, x means here at the value of independent variable x at which the function is to be calculated. Okay, this is equal to yn. Yn, what is yn there? Yn means it is the value in the table just that is to be assumed. And this is here, and it should be taken at the last value, or it can be taken as the just value which is coming at the next value to the just that is the value of x which is at which the function is to be calculated. So yn plus u into nabla yn plus u into u plus 1 upon factorial 2 nabla square yn, and then so on. Look at the difference among these two formulas here. In this formula, del operator in the forward formula, del is coming there. In the backward interpolation formula, nabla is coming there. You can see there throughout. And there is like u into u minus 1, u into u minus 1, u minus 2 means negative signs will come there. While in the backward interpolation formula, these will be just converted into positive. So u into like u plus 1 or u into u plus 1, u plus 2 and so on. Okay, now we are going to take some example. One example we are discussing here, in which here both formulas will come there, and how these two formulas can be applied to just find the unknown value of function. So in this formula here a table is given that for the variable x and y means the function fx, and this is the table. Okay, it is starting with 1921 to 1961 and the values of y are given, and now the question is here we have to find y means the function y at 1936 and the function y at 1963. Okay, so now I am taking the next slide and see this one here. First we have to make a difference table there. As already we know that here, how can we just make this difference table? We have discussed already. These are the values of x. Now we are taking the values of y, and then here just we are taking the differences. The differences will be calculated in a similar way for the forward and the backward and the central differences. Just notations will be different there. Okay, so like see this one, this value minus this value will give us this value here. Now here this value minus this value so this value like means here if we take subtract this value from this value, then we will get this value. In the similar way for the second difference, if we subtract this value from this value means this minus this, if we do this one here, then we will get this second difference value, this second difference value, and in this way a table is to be made there, is to be prepared. Now here, how can we apply the formula here? Look at this one in the next table. See this one here. First for the 1936, 1936 because it is coming in the beginning of the table, so that's why just we have to use the Newton's forward interpolation formula. And here look at this one, what is x there? First we have to calculate u there. U means here it is here equal to x minus x naught upon h. And what is x naught? X naught is taken as the first value. Just we can see this one again here in the table. Look at this one. It is here 1936 at which y is required there. So we can take 1921 as the first value means x naught, or we can take 1931 as the value that is x naught. So look at there, I have taken here 1931 as the first value, that means it is x naught, and x means the variable value at which the function is required. So 1936. H means the width of the class interval, and that is here 10. So ultimately U is coming there 0.5, and now here again I have to explain in the previous this here. So look at here what just how the notations will come there. I have taken this one as x naught. So see this one again here. Just this is taken as x naught, this is taken as y naught. Okay, because this the difference of these two is coming there, so this is called del y naught. Okay, now here the difference of these two is coming there. This one is here, and this is given by del square y naught. Look at this one here. The second difference is coming there. Now the difference of these two is coming there, and this is given by here, and this is called del q y naught. So as already we had discussed in the last lecture, look at the y naught, del y naught. So a symmetry is coming in this way here. We see this one here. So just these are the notations: y naught, del square y naught, and so on. Just in the next slide here, we have to put in the formula of Newton's Gregory forward interpolation formula, like it is here, y naught, it is u into del y naught, then it is u into u minus 1 upon factorial 2 into del square y naught, and then so on, and ultimately when we solve this one here, and we will get the value 49.31, and this is the value of function y at 1936. Okay. Now the next part of the question is to find here the value of y at 1963, because 1963 again I am explaining you here, because look at this one, 1963 is coming at the end, at the bottom of table. That's why Newton's backward interpolation formula is the appropriate formula to find it. So in this way, what just I am taking this one as xn, then it is here yn. Next it is here nabla, because we are discussing, we are saying it is backward interpolation formula. So nabla is the notation, nabla yn. Then here it is nabla square yn. Okay. Next it is here nabla cube yn. Nabla cube yn. Or just one of the thing I should do here. Again I am saying this one as yn. It is here nabla yn. Then it is here nabla square yn. It is here nabla cube yn. And this one has last the value of nabla fourth difference. Okay. So look at again here in the backward difference formula, there is a symmetry of notations will come from the last value, and in this way that does in the increasing order. So that is these are the notations here. The last value I have taken as here xn value, and corresponding value is yn. Okay. Now I am going to apply these values just in this Newton's backward interpolation formula. This is Newton's backward interpolation formula. U is taken as x minus xn upon h. X means here 1963. It is 1963. And then here xn is I have assumed here 1961 is the xn, and h is taken as here 10, because it is already in the given our table. H means the width of the class interval, that is 10, and it is coming 0.2. Now here just we have to put the values from the table to this here, and I will get the this look at here. This is the result of this value. So after solving, we will get this value 97.9493. Just we can use the scientific calculator to solve it here. Otherwise, an error will generate there. So we should solve the throughout equation, this throughout values in the same way, same order. And this 97.9493 is the value of this function yx. And ultimately this is the value at 1963. And with this I conclude my today's lecture. Thank you.